Okay, so in this video, we're going to take a look at how to set up the Google Colab, and basically we'll install, which is very straightforward. Just simply means you have to have a Google account and load in an app, and then you can run code directly in the browser. So just to get the ball rolling, I'll go into a Google account. This is a new Google account, Google Drive, fresh, so there's absolutely nothing here, but typically you will have files and you'll have some online storage. And to create some new content, like Google Docs or Sheets, we just go to new. Now in this instance, I want to set up and run Python code in the Colab, so I need to connect to more apps, and we go into the Google Suite Marketplace, and I look for Colab. So just put in C-O-L-A-B, Collaboratory, and it appears here, and we just add in and install and continue, and we use it here in conjunction with that account. And then we say okay and done. Okay, so once that's done, we can then come back here to new, come down to more, and you'll see here we have Google Collaboratory. Let's just click on that, and again it opens in the browser, and we basically get an online, very similar to a Jupyter notebook, and we can execute Python code and run some interesting graphics. So to do a test then, I'll go into, I have a portal with some code for Python. It's Black-Scholes Merton, and I'll just take some code here that does a little bit of estimation and graphing. And take a look. I think it's the first one, not the first one. It's this one, graphing Black-Scholes time value, intrinsic value in Python. So basically, I copy this code, which is going to run estimation of the Black-Scholes model for a series of stock prices, and then compare time value parabola against intrinsic value of the option. I go back into the compiler. We can give it a name. Of course, we probably want to say for work, so it'll be Black-Scholes, and we can say graph, right? We can say graph. Let's enter the code in, and it's Control V. So Control V. Our code has gone in. We don't need to print everything off here, so I'll just neutralize that. But basically, what we have is I load in the necessary libraries. So import mat, import matplotlib, and the assorted libraries. Import, we need some functions for natural logarithm, taking the square root, getting pi, and the exponential. And we, okay, so what do we have? We have typically a D1, a D2. We're going to run a Black-Scholes call. We're going to invoke the Black-Scholes call function using these parameters. Instead of having a single input for S, we're going to take a range that goes from 10 to 200 in steps of 20. And then otherwise, the exercise, the time period, the risk-free rate, the dividend yield, the volatility are constant. Okay, so let's just execute this code just simply by hitting this execution button. and that will produce a graph, right? So we have basically a time value, Black-Scholes parabola, the time value graph, and then the intrinsic payout. Intrinsics are the value of the option at expiration. Okay, so that's the Colab, and we can save it, file save. So we save. Let's close it down, right? Close down Vinegar Hill, go back into our drive. So we can see that it's there. We can open up and the code is still intact and the graph. So we can, once we've executed the code, saved it, we can find it again in the Google Drive. And that's one of the nice features about this. Also, we can share with different groups that we might be linked to. We can copy a link. And so collaboration then is fully available. And this is free. So one of the good aspects about this is that we have a free resource. It's not completely unlimited, but for most purposes, we probably are not going to exhaust. For a single user in a non-commercial type setting, I think the resources that are available are reasonably accurate. Speed can vary from time to time, depending on usage on the server, but by and large, I haven't run into any difficulties so far in terms of speed of computation. Okay, so it's a really good tool, like it a lot, recommend it strongly.